All right, real quick video on autorhythmicity in a nutshell. So on this top graph, I want to draw what an action potential looks like in a normal neuron. Okay, so we're sitting here before any excitement, and we're at this hyperpolarized or polarized state. Let's just take out the hyper. We're at a polarized state. We're at minus 70 millivolts, meaning the inside is negative. And then we have to have some excitation that gets us to threshold. Once we get to threshold, this opens the sodium voltage dependent channels, and what we see is rapid depolarization. Rapid depolarization, and that's because of sodium influx. Sodium rushing into the cell. As soon as the inside of the cell becomes slightly positive, we see the second phase, which is repolarization. And during repolarization, the inside of the cell becomes more negative, and that's because of potassium efflux. And then we return right back to our polarized state, okay? So there's our basic effect. Now, if we have this initial phase right here where we have to get to threshold, and the way we get there in a normal neuron is this is where you'd see a graded potential. So some sort of stimulation of chemically gated channels or mechanically gated channels. But once we get to threshold, we have sodium influx, depolarization, potassium efflux, repolarization, and then we're back to normal. Okay? So phase 2, depolarization, sodium influx. Phase 3, repolarization, potassium efflux. So what we would see in autorhythmic cells, so this would be in the SA node. It would be the same in the AV node. So they're autorhythmic. So what we see is over time, they just keep on regenerating action potentials. And phase 2 and 3 are identical, right? So we have this rapid depolarizing wave, and that's as a result of sodium influx. You have this repolarizing wave, which is a result of potassium efflux. Okay, now what's different is number 1. So number 1 is the pacemaker potential. So the pacemaker potential will, instead of just holding at 0 like in a neuron, the pacemaker potential automatically regenerates back up to threshold. And so what that means is that there must be either a large amount of sodium leak channels, right? So this is depolarizing, so sodium has to be coming into the cell. So there has to be either a large number of sodium leak channels, or there have to be a bunch of chemically gated sodium channels, and this is probably what happens to speed up the heart rate. We can get to depolarization quicker if we have some stimulation of the SA or AV node that allows us to get to threshold quicker. So that's just a quick summary of the difference between a normal action potential and the pacemaker potential's autorhythmicity in SA and AV node in the heart.